So in this video, what I've decided to do is to go through some of the questions on the C1 Quadratics in disguise worksheet that I've given you for homework. So let's just look at each different type of a question. So what could you have? So one type of question, let's pick question 5. You could have 2x to the power of 4 is equal to x squared plus 1. So first of all, you notice that you've got x's in two places. One x has the power of 4, the other x has the power of 2. If the powers of those two terms are one is double of the other, then it will be a quadratic. So you could see if I times that 2, which is the power, by 2, I'll get 4. So what this tells me, I can replace, let y equals x squared, and then this time y squared will be x squared squared, so x to the power of 4. I have got now a new quadratic. 2y squared is equal to y plus 1, and then you rearrange it and solve. So we are only interested at this stage as how to get to that stage, but just for this one, let's just factorize it. Okay, so it's going to be minus here, plus here, and then you've got y is equal to minus a half if you carried on, or y is equal to 1. Then you would return back to your substitution. X squared is equal to minus a half. No solutions here because you can't have anything squared being negative. Or x squared is equal to 1. So here you've got x is equal to plus or minus 1. Let's look at the second type. So you could have, let's go through. Let's have a second example with square root. Let's do one, I think 6. 6 will work. You've got x plus 3 is equal to 4 root 3, root x, sorry. So over here, if you think about the powers, you've got x to the power of 1, and then here you've got x to the power of a half. And if you compare the two powers, you will have 1 and a half. So this one doubled will give you this one. So this one will be equal to y, and this one will be y squared. So if you rearrange it, you've got 4y plus 3 is equal to 0. Then you just factorize it. That's all I've asked you to do. And then go back to your x's. So you're going to write it as x, square root of x maybe, rather than x to the power of a half, but both will do. There you go. And then you can carry on from there. Okay, so let's have a look at another type of question. So that's 12. 12 is interesting. You've got x to the power of 2/3 plus 5x to the power of 1/3 minus 4. So if it can be factorized, then we'll be all right. But you need to look at the powers. This one here, x to the power of a third. See what happens if I square it. I'll have x to the power of a third times 2. This is x to the power of 2/3. So if I make my y equals x to the power of a third, then y squared must be x to the power of 2/3. I clearly doubled that to get this. So it's 6y squared plus 5y minus 4 is equal to 0. Okay, so try to factorize it. So let's try this one. I'm doing by inspection, so if I put 4 here and 1 here, that would work. I wouldn't put 4 here because it's already got 2 there. So that will be, yeah, that will be 3 and 8. So I can make 5 by making 3 negative and that positive. Obviously you can use your grid method. So y can be replaced with x to the power of a third. So it's third minus 1, x to the power of third plus 4. And then you carry on solving. So obviously at this stage we're not interested in solving. Another type is the one with, again, with some powers. Let me just check what's question 16. Okay, so the first one, let's do 17. So it's 2 to the power of 2x minus 12 times 2 to the power of x plus 32 equals 0. So you need to think this one is smaller, has smaller power, this one has bigger. So see what happens if you square 2 to the power of x. You are going to get 2 to the power of x multiplied by 2, which is 2 to the power of 2x. So indeed, if you let y is equal to 2 to the power of x, then clearly y squared must be replaced with 2 to the power of 2x, or is the replacement for 2 to the power of 2x. So you can write that. And if you can factorize it, go ahead and factorize it. So this is going to be, 8 and 4, I think. Yeah, that will work. So 2 to the power of x minus 8, and then 2 to the power of x minus 4. Okay, let's just do one more interesting question. It's the one where you have something going on with like x plus 2 in the power or something similar. So let's do the last question. So 3 to the power of 2x minus 3 to the power of x plus 2 plus 20 is equal to 0. So that's question 32. So over here, now you need to separate this into the product of two terms. So 3 to the power of x, and then 3 to the power of x and the constant 3 to the power of 2. This is 9 times 3 to the power of x. So really, that's the first step. There you go. And then you're going to replace that single x, 3 to the power of xy. If I square it, I get 3 to the power of 2x. So you get a quadratic. And then you try and factorize it. Will it factorize? 2, 4 and 5. There you go. Okay, so this is going to be 3 to the power of x minus 4 and 3 to the power of x minus 5. Obviously, we are not solving it yet. Okay. So hopefully that helps. Just a quick note on question 16. I did go over that one in the lesson, I think. So you have root z, square root of z minus 4th root of z is equal to 3. So you need to realize that this is z to the power of a half and this is z to the power of a quarter. And if you let y is equal to the smaller one, see what happens when you square it. You have z to the power of a quarter that's squared times the powers. You get z to the power of 2 over 4, which is a half. So it is y squared minus 2y minus 3 is equal to 0. Carry on. Okay, thank you.